Thanks everybody for coming, and thank you so much to the award selections committee. I'm really, really honored to be here and doing this. I love CNS, so it's really nice to feel some love back from them. Okay, so before I get started, I want to start with some thanks to, there's this quote from Newton, if I've seen further, it is standing on the shoulder of giants. And I have been so fortunate to have a set of mentors that I could stand on top of to do my science. First, I want to thank Allison Adcock, who's in the front, who taught me how to think big, to think about big ideas that matter, and then how to constrain those huge, wonderful, complex ideas into like really elegant experiments to really make meaning of the world. I want to thank Kevin Labar, who, simultaneous to all this, helped me learn sort of the structure of what it means to be successful in this field and how to proceed through it. For those of you who've met me, I'm like a real softie. I'm like a real softie and a pushover. You can ask my lab. And beyond all the amazing things Layla taught me as a scientist, during postdoc, she also taught me what it looks like to be so strong and kind at the same time and to execute both simultaneously, which I'm extremely grateful for. And then I thought my world of mentorship was over once you finish your postdoc, but I also want to thank Ingrid Olsen and Nora Newcomb, who at Temple have just been, selflessly kind in helping me throughout my career, and Ingrid especially, who nominated me for this award. Okay, but it's not just the mentors. I quote myself now saying, girl needs some support to not be blown away. One of the beautiful things about being in cognitive neuroscience is we have this wonderful community that tracks you along the way. I started off with a great set of colleagues in grad school, and I especially want to highlight Maureen Ritchie and Joey Dunsmore. Not only are they wonderful friends, but they're wonderful friends that like study eerily similar things to me, so I can bother them on all dimensions, which is really great. This continued through into postdoc, and I need to give a special shout out to Oriel too, who again forced me to just start thinking beyond memory on its own, and you're gonna see the resonance of that, of having somebody push me to think bigger about my work and not let it sit in this siloed field. And then Temple has just been an unbelievable resource of young, fresh faculty that are, again, friends and research mentors along the way. The last person I want to thank is Sarah Dubrow, who unexpectedly passed away. And my time with her was too short, and she was one of my favorite people in the world. But as Sarah always reminded me, time is a fake thing, and it's just a reconstruction of our memories. So as I grieve, I just want to focus on the positive memories that I have of her and how wonderful she was. Okay, but let's get to science. So, memory research, right? It's the best. Sorry, Oriel. Memory research is the best. But there's a long history of memory research, and we've been doing it for a while, trying to study how does memory selectivity emerge, right? Why is it that some things stick with us forever, other things disappear and move into the background? And starting early in grad school, I was interested in this question, but with the slightest pivot, which might seem really small, but is actually huge of a difference, is not asking how memory selectivity emerges, but start to really question why memory selectivity emerges. Why is it that we hold on to some information versus other? So making a talk like this really gets you in this like nostalgic mood to think about the past. I was like, oh, I really need to think of an example from grad school to share with everybody. And literally the only memory from grad school that I could remember is during my dissertation defense, I was so nervous, and instead of saying hippocampus, I said hippocrampus. Terror, right? Terror. And we might ask ourselves, why is it that this memory is the one that pops out of all of them, right? It might be because it was a really high arousal event, and there's been beautiful models of emotional memory that show how things like arousal and the intrinsic content of a stimulus can drive your memory up. But working with Allison and Kevin, we wanted to take sort of one step past this idea of emotional memory, which is so bound to the stimulus content itself, but also to understand that goal states might also drive why some memories pop out over others. So it could be that I remember this because I remember also how handsome and wonderful I looked in glasses. And I'm like, oh, the reason I'm really remembering this memory is because I look really smart in glasses. But what's even more awesome about our systems is that they're really idiosyncratic, right? So it's not just general adaptive goals of the world, but it is goals that are tailored to one unique individual, right? So most people thinking about this memory might think, wow, it's embarrassing to mispronounce anatomy during a talk. I need to be really careful about it. But if you have my own internal world, I have reconstrued it to be that mispronouncing anatomy is an adorable way to get positive attention, and that's the true story of why this memory pops out. But in all earnesty, it just serves this idea that we tailor our memories to help solve future goals in a way that is really idiosyncratic and awesome, right? But how do we do this? So what I'm going to talk about today is some background work that sort of got us into this domain of motivational valence. And that's going to be mostly work from grad school. Then I'm going to talk about some new stuff my lab's been doing, where we unpack these two motivational states, both in the context of diving deep into what these memory phenomenology are and clinical applications of these different types of frameworks. So we'll do this both in an interrogative state and in an imperative state. But before that, what do I mean when I'm saying interrogative and imperative? So in grad school, I walked in and Allison was my reward boss and Kevin was my threat boss. And I was like, we're gonna study both of them together, reward and threat. And we're really focused on rewards and punishment. But as we sort of evolved in our thinking throughout grad school, we realized these weren't the right words to describe the phenomena we're thinking about. And here's an example of it is imagine you're getting ready to study for a test. It's a reward motivation state because you want to do well on the test. Some people that are saying to themselves, gotta get that A, I really want to get that A. Some people are like me that are very anxiety prone, and it's like, don't fail, don't fail, don't fail, don't fail, don't fail, right? And in both of these, it's a reward-seeking behavior, but there's a division in how we're approaching it. So in a review paper, Allison and I proposed sort of a reconceptualization of motivational states to interrogative states that have to do with exploring the world and being curious and trying to solve multiple goals at the same time, and that's how you approach the space, versus an imperative state where it's sort of like, oh no, there is a single urgent threat in the world and I'm gonna divert my resources to that threat, right? And what we noticed across a lot of work, both animal work and our own human work, was that when you're in these different states, in these interrogative states where you're sort of curious and exploring, you get basically highly integrative maps of the world, items, the context that were there, the relationships between them. But when you get into these imperative states, you're sort of narrowed down to that sort of sole source of the thing that is really urgent, and it might give you sort of a memory representation that's quite strong, but it's decontextualized from all the things that happened around it. And if you're a memory buff, you know, this sounds very familiar to frameworks that have been proposed for a really long time in the domain of episodic memory, that the hippocampus itself is really important for this relational binding. Across things, it might be more aligned with interrogative states, whereas engagement of cortical medial temporal lobe, like the perirhinal cortex or perihippocampal cortex, it might be more responsible for generating these unitized states that don't have the relational connections between them, but can still have really strong representations of stimuli that we encounter. So how did we go about studying this? By we, it's actually Allison first, but she set up a really nice paradigm where you can give people cues, so basically put them into the motivational state that you want to study, and then basically attach that incentive state to a picture, and you want to learn that picture. What's critical about these paradigms is that encoding success, meaning how well you're able to remember this information at a 24-hour delay, that's what determines your reinforcement. So in the moment, there's not reward feedback. Like, this isn't RL learning, right? This is about engaging an anticipatory motivational state and how that shapes your new learning. So Allison in 2006 did this with monetary rewards and saw that you got engagement of regions overlapping with mesolimbic dopamine systems that we know have to do with exploration and curiosity and plasticity, right? So really well aligned to this model. But then when we looked at it with threat, which as a side note, in grad school, I accidentally ran the Milgram cover story as a real study. And it didn't take me till like 6 years later till I realized I ran the Milgram experiment with Allison and Kevin. But when we look now, when you're sort of motivated by avoiding a shock to learn information, we didn't see any engagement of the VTA predicting memory success there, but rather saw engagement of the amygdala, right? So already we're seeing sort of a discretized engagement of the neuromodulatory systems that might be driving learning and memory. But we know the VTA and the amygdala aren't sort of driving these memory systems in isolation. We also know they need to engage with other regions of the MTL to have the memory readout. So in another study, we looked at these two states side by side. And in this study, what we did is we had cues, again, to incentivize individuals, and then they had to respond to a target later, and that target would determine their reinforcement in this task. But what we did is embedded in this motivational state, we showed individuals surprising stimuli, and then we could examine how does the medial temporal lobe respond to these surprising stimuli if you happen to be in a state of reward or if you happen to be in a state of threat. And we saw this gorgeous double dissociation where if you were in states of reward, you got more engagement of the hippocampus encoding this surprising stimuli, but if you're in states of threat, you got more engagement of cortical MTL encoding these stimuli. So this is really exciting. I guess I'm telling you all it's exciting. I find this really exciting, hopefully you agree. But what is missing from the narrative so far is that I haven't told you anything about memory, right? And again, I think the important part of even studying the brain is to look at what it is doing to your actual memories that you're using in the world. So I'm gonna show you a lot of data summarized across sort of 3 bar plots, basically 5 years of work for one slide. Don't worry, trainees, it gets better. So when we look at unitized memory, right, this is just, do you remember this item or not? We don't care about context, we don't care about anything else. Do you remember this item? We would predict that both reward and threat states should enhance memory for this, because this is something the hippocampus could do, it's also something the cortical MTL can do. And when we look at this, no difference across reward and threat states in acquiring this information. However, if you look at more relational memory that involves binding of different features of the environment together into a flexible representation, here we would make the prediction that reward would enhance it, threat would impair it. So we had individuals do a virtual Morris water maze task that we know relies on these types of flexible relationships to solve the task. And here we see, we see a dramatic difference that the reward-motivated states were actually making you better at doing this associative learning task, and the threat states were actually making you worse, meaning we're telling people, learn this information so you don't get a shock, and they were doing even worse than a non-motivated condition, because that's not the types of memories we think that it is supporting. Similarly, if we looked at that surprise memory paradigm I showed you in the last one, we saw that the reward state was sort of helping you pick up extra information in the world that might be goal irrelevant, but maybe it's relevant, maybe it's not. It's giving you sort of a breadth that feels a lot like exploration, whereas the threat state was having no difference on that external information. So with all this work, we put together this model about how these different interrogative states and imperative goal states will engage different types of encoding mechanisms, with interrogative states driving the VTA towards the hippocampus, the imperative states driving the amygdala to the cortical MTL, and then causing very different types of representations in the world, showing that it's not enough to just think about motivation being motivation being motivation, but you have to think about the flavor of the motivation in terms of driving what type of mnemonic representation you're gonna get. I'm gonna give a little bit of warning that we're gonna use reward and threat to look at these two states, but it is much more complex and nuanced than that. These are sort of the easiest tools to get through these states, but if you think of a drug addict that's waiting for their next hit, that is a reward state that is gonna get you into an imperative goal state. Or if you just really need to get that money, the choking on the money phenomenon, that can also drive you into an imperative goal state. So I just wanted to add a little bit of nuance while I also tried to tell you 13 studies in 30 minutes. Okay, so, when I got into my own lab, I was really excited about these frameworks, but there was a part of me that just wanted to dig deeper into memory phenomenology, underlying these interrogative versus imperative motivation states. So we wanted to take these ideas that in some ways still felt a little bit two-dimensional because they were new, and make sort of a three-dimensional understanding of what they mean. And we wanted to do this in 2 separate ways. In the first batch of studies that we did together, we were really focused on accuracy, right? Like, was the memory there or not? But we know that memory is so much more than just being there or not. So we also wanted to study things like, what's the structure of the memory? How are you organizing information in different ways in your head? What's the form of memory? Are you really focusing on things like perceptual details or semantics or episodes, or the content of it, of sort of this vast array of you are in this room? What am I actually gonna pick out of this when I knock down this memory of this event? Another way we can make these sort of two-dimensional ideas come to life more is to think about psychopathology, so sort of moving a little bit outside of the space of just the lab and trying to understand how distortions of these types of, networks or motivational states actually cause differences in the real world that might actually lead to maladaptive behaviors rather than adaptive behaviors. So what I'm going to do in this talk is first sort of lean over to the interrogative side, and first go over some things we did to understand memory phenomenology, and then talk about clinical applications on that end. And I'll start with memory phenomenology first. Okay, so just as a reminder, the model that we started with is that you have these interrogative goal states. It engages the VTA in the hippocampus, leading to more relational memory. So I recently moved into a new apartment, and I'm framing this as a reward state because I went to IKEA, but I know that's a threat for a lot of people, right? But I didn't have any goals in mind. It's like, what are we going to decorate for the house, right? So you can imagine I'm in a really reward-motivated state to pick out the new things that I want to put in the house, right? And under this model, what we might think, and I think early in grad school, this was the way that I was thinking about it. I think Allison was a lot more elevated than me at the time, but the way I was thinking about it was like, okay, you got the hippocampus going in, this representation gets in there, you're just gonna stamp it in, right? Like what the VTA is doing is having dopamine in there, let's stamp in that memory representation. And what I mean by stamping it in is that you would get sort of the same way the event unfolded in real time as how you would store it in memory, right? So if I saw this thing first, then this thing, then this thing, then this thing, when I go back to my memory, it's gonna hold that same type of organization in it, right? But the more we started to think deeper about this, and really inspired by a study by Emily Cowan, my postdoc, and Matthew Fain, who is right there on the right, she was looking at this, albeit in the state of novelty, but was looking at circuits of how novelty and VTA engagement changes the way the brain is structured using resting state fMRI. And the things that Emily found was novel experiences that engaged the VTA were more biased towards causing plasticity changes in anterior hippocampus versus posterior hippocampus. And more broadly speaking, when she looked at large-scale memory networks, popularized by Maureen Ritchie, we specifically looked at the anterior temporal networks, and we were seeing that the VTA was engaging more with these large-scale networks, right? If you're not in the memory world, this would be like, so what, right? But when you sort of map these circuits back on to the types of things that we know they do, these are the types of circuits that guide things like flexible relationships with the anterior hippocampus versus posterior. And these anterior temporal networks are really important for things like abstract concepts and semantics and higher order thoughts, right? So if you take this as a source of inspiration and this knowledge we know about these networks that are being engaged, and revisit this classic model that things are going to be stamped in the exact same way that you encoded them, it sort of starts to not make as much sense. And we updated this model now to think more that yes, you can still keep this associative structure and you can still keep relationships to it, but that doesn't mean it's going to make it exactly the way that you encode it. And you might want to restructure information that is related to each other together, and then that way they are sort of more easily accessible as they're sort of compacted together. You might want to actually then include information that didn't happen during that event, but is related to that event, and incorporate that old knowledge in with your new knowledge. And on that line, you might not even just pick actual specific episodes of related information and bring them in, but really just sort of have like a semantic concept, right? A concept that then can also get embedded with these episodic details. And this might be the way that we're storing memories under reward. So my graduate student, Elizabeth Horvath, tackled these questions, and what she did is she took some of our classic paradigms where we're paying people to learn pieces of information, and the critical switch that Elizabeth did is instead of doing recognition paradigms, she switched to free recall, right? So we show people high and low reward words, have them then recall as many words as possible as they can, and the clutch part about this is with free recall, we can start to unpack the structure of memory because we see how they're organizing it in their head. So the first thing we looked at was, can we replicate these findings that we see in recognition? People recalled more words from the high reward category than the low reward category. So it's not like recall is doing something wildly different to it. But the important part now is we can now look at how things are organized in memory. And what Elizabeth found is even when accounting for the accuracy differences across conditions, what we saw is that individuals started to cluster their high reward information together such that if you started with one piece of high reward information, rather than jumping to the next thing you saw, you would jump to the next high reward thing that you saw. And this way it gives us a sense of how these de novo categories can restructure the way memories are stored in our head. We wanted to go one step further and try to get a better understanding of exactly what types of mechanisms might be driving these behaviors. And inspired by Mike Kahana's context maintenance and retrieval model, we took a computational modeling approach. And in Mike's model, which if you don't know it yet, you should know it, it's awesome. You have all these items that exist in the world, and as you are walking through the world, these items get bound to a context, right? Then when you get to recall, you might see one item that's gonna basically like pop up into your memory layer and reactivate not only that item, but the context that was embedded to it, and then that context is gonna then trigger the next thing that you pull into your head. And within the CMR, it's such a nice model. It has all these different types of mechanisms that can shift people's free recall dynamics. So in one iteration of it that Sean Pollan worked on quite a bit, you can introduce these source layers into it, so information can get coded with sort of additional contextual information that isn't just time. In our case, we wanted to look at value. Can you tag this to a value type of source in addition to the temporal source? We can also look at learning rate, which is how strong are these items getting embedded into their context. And then we can also look at drift rate, which is sort of the uniqueness of it to its neighbors, right? Like how isolated is it or close to other things that are sitting in your memories with each other. What we found is the best simulations from these models that reflected our data, both in terms of accuracy and clustering, was a combination of this source memory and learning rate. Either one on its own wasn't enough, so it wasn't just good enough to increase how much it's getting bound into a context. You needed sort of a separate set of area for the high value items and low value items, and then in combination you can get this type of clustering effects that we're seeing with our data. So this was pretty exciting, and it fit well with the earlier neuroimaging data that you get these higher order concepts in driving results. But in these experiments particularly, it was all about de novo categories you're making on the fly, right? So you're seeing the information in real time, a new category is introduced of high versus low value, and then you're splitting that information up in your context layer. But Elizabeth was also really interested not just on these de novo categories that come up on the fly, but what about pre-existing categories that have existed for a really long time? So we went back to readapt an old school paradigm of the DRM effect. And for those of you not familiar with the DRM effect, you see a bunch of words that are semantically related to each other, but it's missing the critical word that sort of ties all of them together. So that is never shown. And what we did is she adapted her paradigms to introduce these in high reward contexts and low reward contexts. So from this paradigm, you can get two measures: true memory, right, which is words that you actually saw during encoding, how often did you recall those? And then false memory, which is how much did you accidentally recall that semantic lore that you had never seen. So what Elizabeth found, which shouldn't be a surprise this far with all the other data, is that you get an increase with high reward on the true memories that you also saw. But if we were right that this is more about higher order concepts or drawing in prior knowledge into the mix, you would also expect to see the same effect for the false memories. And indeed, we see an equal magnitude effect for these false memories, the same as true memories, which is suggesting that the type of representation that might be being targeted by reward motivation isn't necessarily these sort of crisp, precise, veridical stamps of the world around us, but something that's a little fuzzier and stickier, meaning you can grab more information and relate them together. And we're even more confident that it's the same representation for the both of these, because the same individuals who had increases in their true memory by reward showed equal amounts of increases in memory for the false memories, right? So taking sort of a step back on this, I'm calling this vintage Murty, really thought it was about stamping in traits exactly as you saw them in the world. But here I think I've been growing to think more about what this type of associative binding the hippocampus is doing. And it's much more not just about sort of stamping in the world as it is, but rather flexibly rearranging it in many ways of what Oriel talked about with their cognitive maps, that they can be flexible dynamics, that you can stick related information in with each other, hold them closer to each other so they're better for things like generalization or abstraction or making a heuristic because we're storing this type of information together. Okay. So that gave us a little bit more insight about what was happening in the context of reward, but then we now wanted to see whether we can utilize some of this information and this knowledge in this framework to better understand psychopathology. So there might be some curiosity of why I would jump from those studies directly to psychosis. And we know psychosis is defined by positive symptoms and negative symptoms and executive dysfunction. For people that study psychosis, it's a really complicated space. There's about 10,000 models that exist at any given moment that just shuffle in variability of what's the model that it seems the most right, but it's a really complicated field. And it's because there's so many different types of symptoms that are associated with psychosis. So things like memory deficits that can often look like overgeneralization or more reliance on familiarity than recollection, things like delusions, aberrant salience detection, and paranoia. And what's interesting, if you take this interrogative motivational framework approach, you can start to see that there's a unified framework to understand how all these things might intersect with each other, right? If you have a system of memory that finds things really salient, but then also really likes to integrate prior knowledge into the mix and generalize into the mix, you can start to have the foundation of things like delusions and paranoia from this sort of crossroads of salience detection and memory deficits. So before getting to Temple, I worked at University of Pittsburgh and had the opportunity to analyze data in individuals with first episode psychosis. And we went about testing how well this interrogative framework maps on to the clinical dimensions of psychosis. And what we found was a lot of evidence that's starting to put together the puzzle pieces that make it seem like this is a useful framework. So first, we saw that there's hyper connectivity between the VTA and the anterior hippocampus in first episode psychosis compared to normative controls. And further, the extent to which you have this hyper engagement within this circuit, the more symptoms you have across participants. In another study, we looked at the amount of connectivity within these anterior temporal networks, and we see that there's greater coupling within the anterior temporal networks in individuals with psychosis versus normative controls. And then finally, we also reanalyzed some free recall data and memory, and we see that in psychosis, there's really prominent deficits in the ability to use temporal context. So, I saw it in this order, I'm gonna recall it in this order, compared to normative controls. But there was like a whisper or a hint that individuals were using semantic information more to guide their memory search of these areas. So together, it seems like it's building a story of connecting these three things in an interrogative motivational framework might give us some leverage to understand psychosis better. And currently right now, these are three discrete findings, but we would need them to all be related to each other for this framework to work. So I have collaborations with Lauren Ellman, who is at Temple University. I'm moving this to a clinical high-risk population, and we're now sort of developing tasks to try to plug these three discrete things together to get a sort of more comprehensive view of psychosis. Okay, so in summary, interrogative motivation biases memory representations to be organized around higher order knowledge. If we put this back to my example, my adorable hippocampus moment can get integrated with other adorable talk moments or knowledge about the power of self-deprecation to make more adaptive choices in the world. And I didn't have time to put it in this talk, but we have a lot of parallel work showing how agency and exploration, these other types of interrogative motivational states, also help construct higher order knowledge in memory as they unfold over time. Who's ready for a pivot? Okay, so we're gonna step away from the reward motivation world and the interrogative motivation world to talk a little bit about stuff that we've been doing on the imperative side of things. So, just as a reminder from the model, imperative goal states might engage these amygdala cortical MTL systems, and it's causing things to get decontextualized with a target on just the sole salient information that is the sort of focus of the goal in the moment. So giving an example of, say you're going on a hike with a friend, you might look back at this memory and there's all these things that are connected on the hike. The delicious apple that you had, the rabbit that you saw hopping across the trail path, and the headphones that were playing the music you were listening to, and a cactus. I don't think this hike has ever happened to me, and that's why you're seeing me struggle reconstruct it. But imagine that all these things are together and you have a really tight representation of all of them with each other that's flexible. But say on that same hike, you hear the rattle of a rattlesnake, you turn and you see it, right? All of a sudden, looking back at that memory, you might lose all that relationship of the world that was happening around this because your attention is narrowed in to the sounds of the rattlesnake and maybe the sights of them, but you lose everything else in this. And what we imagine is happening in this case is that the sensory information may overshadow the construction of cogent narratives, right? You've lost the pieces that you need to glue a cogent narrative together because of this emphasis on perceptual details. And we were really interested, there's a ton of work, beautiful work by Elizabeth Kensinger and Mara Mather, looking at this trade-off between item and context. But one thing we're interested in is, okay, what's the consequence of this trade-off, right? What does it do to the stories that we tell ourselves? But to study this requires us to have a really high arousal event that's continuous and unfolds over time so we can look at both states at the same time. So luckily, Philadelphia is host to one of the most spooky haunted houses that exist. And in a collaboration with Chelsea Hillian, who's over there, and has beautiful work on the emotion regulation side of the study that I won't be talking about, we wanted to study memory for individuals going into a real life haunted house. So we had participants go to the haunted house. They had heart rate monitors on so we could track their arousal in the moment while they were going through this haunted house. Then they came back a week later for free recall. Because Oriel brought up Tillman, I will too. I think his great-great-great-grandson must have designed this haunted house because it's like a 6-arm radial maze, which is like eerie. It was waiting for a psychologist to come on board. But in reality, what was really nice about the haunted house is that it did have separate segments. Each segment had a different theme, so one might be like blood and hospital, and another one's like scary clowns, right? But the beauty behind this type of layout is that like I might be really terrified of scary clowns, Allison might be really terrified of blood, so we have these idiosyncratic fear responses that happen across segments, and we can leverage that individual subject variability to better understand what threat is doing to memory. So overall, it was effective at being a high arousal event. Individuals had much higher heart rate in the haunted house versus the lab where we treated it as a baseline condition. And we know this is important, heart rate arousal measures, because this is work from Chelsea's lab showing that the extent to which your heart rate increased in an individual segment of the haunted house, the more fear you rated as experiencing in that segment. So this is a good marker of threat-related arousal. My boyfriend at this time said that my talk was boring and I needed to spice it up with some photos when I went over with him. So this is the outside of the Eastern State Penitentiary where people went. You walk through rooms like this, very spooky, and then you also ran into characters that were really threatening, right? Like somebody behind you with a chainsaw was coming after you, and then these are the types of things we were testing memory for a week later. So what did memory look like? Rather than jumping straight to graphs, because I feel like that sort of loses the essence of the experience, here is a narrative of one of our participants' recall from it. There was a lot of blood everywhere in that room. There was someone with like a saw at one point and a guy holding a saw that wasn't a chainsaw and walking around following people with it. I think there were nurses in the hospital room or doctors, like gory nurses and doctors, right? You can start to get this feeling of how much sensory detail is embedded in this. But let's move from qualitative to quantitative. What we did is we used an autobiographical interviewing framework developed by Brian Levine to capture the content that was in these free recall narratives. And we can now, using these measures, get a sense of how much perceptual bias was there in individuals' memory narratives and how much is that related to the amount of arousal they had in the segment of that room, right? And what we found was that the greater threat-related arousal you had in an individual segment, the more likely you were to bias your memory representations over towards perceptual details rather than the other information in the environment. So this sort of gets at half the story, right? The idea was that sensory overload might be actually drawing you away from making a cogent narrative of the entire event. Here's the sensory overload half of it, right? But what about the cogent narrative here? And typically, pre-Temple days, if I was looking at cogent narratives, I would just sort of like find some type of textual, structural analysis to look at the cogency of the narratives. But to my blessing, I have been inundated with wonderful new social psychology colleagues that are inspiring me to look at the world in a more expanded way, specifically Chelsea Hillian and Johanna Jarko. And thinking sort of in a space with them, we got to we wanted to get at social communication, right? This is what we mean by a narrative. A narrative isn't to feed into a computer. A narrative is to share with other people in the world. So Ian O'Shea, who is also here somewhere, worked on this study. And in this study, we took the narratives from the haunted house, right? And what we did is we now sent these to strangers on the internet, and we had them rate how confusing was each narrative, right? Rather than trying to capture the textual analysis of the narrative, we said, no, let's use real humans and have them rate, how much is this a cogent narrative or not. And what Ian found across two studies, in the first studies, we just picked the narrators, the memory tellers, that had the lowest threat-related arousal and the largest threat-related arousal. In study 2, we just sampled the whole course. But what Ian found was the individuals that had greater threat-related arousal also produced narratives that were less understandable. And we have whispers of data that the amount of perceptual bias in these narratives is actually driving this relationship between these two things. But it's like, don't quote me on that yet, room of 500 people. It's still in the works there, but it's looking like it's that way. And what was really neat about this data point, it wasn't just their narratives of the haunted house alone that was getting disrupted, but also their narratives of what they were doing in the lab, suggesting that this arousal state may generalize beyond just what you're looking at in the moment that evoked the arousal, but other things that are related to it more broadly. So this was particularly exciting in terms of thinking about it in the clinical framework to PTSD, because there's been a ton of work, a lot of inspiration from this came from David Rubin, that one of the major challenges in PTSD is the inclusion of threatening events into your own narrative framework. And there's a ton of really efficacious therapeutic tools that actually work on narrative construction with individuals who have experienced trauma. And it's quite beneficial for them to be able to draw narratives around this. And what's interesting is that has come mainly from a cognitive psychology view and a clinical work view. There's been also a ton of work in neuroscience and clinical neuroscience showing things like reduced hippocampal volume, hyperarousal during fear conditioning, impaired extinction, increased threat generalization. I'm just reading Joey Dunsmore's research out loud for all of you, right? But all these things exist. But again, we had this moment like we did with psychosis that we can actually use our model again and start to construct a way that all of these might be unified into the actual same sort of feature space that's resulting in things like disrupted narratives or fragmented narratives in PTSD. And we got a really awesome opportunity, and this is work with Bushra Tanraverdi, who's also here, to start studying this part of this awesome study called the Aurora Project. That was a multi-site project that scanned like hundreds of people 2 weeks after they were in the emergency room for trauma. Most of this was motor vehicle collision trauma, but there's also physical and sexual trauma that's embedded in here. And what's interesting about the 2-week marker of PTSD, or following trauma, is that up to 75% of people will have symptoms that could get them diagnosed for PTSD. But then this number dramatically drops as you look out to 2 months or 3 months. So there's something really special about this 2-week window that tells you something about the state of the system. So what we did is we had individuals doing a threat reactivity task where they were looking at fearful faces and neutral faces, and we were assessing hippocampal function, right? And if you're in this world that's like, oh, the more emotional responses, that's the narrative of what's causing PTSD symptoms, you would predict a really strong positive relationship between these two things, right? More threat reactivity is driving these PTSD symptoms. But if you think of the models that we've been talking about, the real problem in PTSD might be that you're not engaging your hippocampus enough and you're shunting those memory representations away to unitize things that might exist in the perirhinal cortex, right? So here we would actually say the clear clinical phenomenology is driving things away from the hippocampus. That was planned. It was a planned callback. Driving things away from the hippocampus in states of threat. And indeed, this is what we found. The less threat-related reactivity you had in the hippocampus, the stronger your PTSD symptoms were, right? But actually diving deeper and thinking about our framework, it's not everybody. The whole story isn't just the hippocampus, right? But it's this interaction between threat-related arousal and the hippocampus. So we now were able, in a separate paradigm, able to look at fear-potentiated startle in these individuals and categorize them as individuals that had really high threat reactivity or really low threat reactivity. And we see that this relationship between hippocampal function and PTSD symptoms is limited to individuals with high threat reactivity. I am going way too over. So hopefully you've seen that it's important to think about motivational valence as a broader framework, and that these different types of motivational states actually lead to much different readouts of the world that are beyond just item memory versus associative memory, or hippocampus versus perirhinal cortex, but they're sort of qualitatively different types of representations of how we store the world around us. And this has different sets of implications for clinical disorders. The lab is continuing to follow up on this in different areas, including looking at intrinsic motivational states like curiosity and information seeking, thinking about this through a developmental framework, as these systems might be operating at different timescales, leading to biases to some types of motivational states over others, and relating that to education. And I showed you a teaser of the stuff we're trying to do with social communication, but we're like tripling down in that area too also. So I want to end with a very much thank you for listening, and we don't have a lab photo yet because of COVID. And I found this thing that said cherish every moment, because it's just really good to be back in an in-person conference. And I really meant it for trainees too, is like, you know, find your pals, because they'll stay with you forever. And, you know, things can be rough, but we got to find those things that we cherish. And I'm so sorry I went so over. I was just too excited. Okay, thank you.